All right, our very favorite Promise.all. There's a new Promise thing, isn't there, coming in a future? It's like Promise.all settled. Have you heard of this?
No, I haven't.
There's like Promise.all settled, and I don't remember the other ones. Okay. Anyway, Promise.all, very important if you're trying to do something with like multiple promises. It basically aggregates them and returns a single promise that I don't know. Am I describing this well, John? You can describe it better than me.
No, I think you pretty much got it.
Okay. So let's take the challenge. We see here, if we pass Promise.all this tuple 1, 2, 3, and we say type of Promise.all is not defined yet, but anyway, what we're expecting it to return is a promise returning the values 1, 2, 3. So it's like resolving all of those values. There's a couple different things here in how to write that. This is a first in the challenges we need to use with the way these examples are written. We need to use declare function. Usually we like make a type alias or something. So I think the syntax is pretty much the same, but yeah, where would you start on something like this?
Okay, this is definitely a little bit more interesting than the previous couple. So let's take a look here. Ultimately, it looks like we're going to have to be working with tuples. So I assume we want to make...
Yep. Constrain
well,
the generic.
first of all, the return type is definitely going to be a tuple, but we also need to constrain the input as well.
Yeah, the return is a promise always of some kind.
Yeah, a promise returning some kind of tuple. So T is going to need to extend, let's see, any tuple. That's actually not the easiest thing to model in TypeScript.
We can just do just do this for now and see where it goes.
Okay, interesting.
See what happens. It's some kind of array tuple thing.
Sure. Yeah, we'll see how that goes. Oh, we don't have the parameter as well.
Yeah, sorry,
so we're
it's
gonna
missing.
Need to type that with T, something like that, maybe. I have the types wrong. There we go.
Yeah, and I think we would have to do.
Right. Would it be? Oh, whoops! My cursor moved.
This. Yeah.
Is that right?
Yep,
Okay,
that's right.
There we go. It's a little bit arcane. You don't use that every day.
It is a little weird. And actually, I have one more thing to add to make it weirder, which is that because of the way these all end up, we need to make it read only as well, because this is not just this is a tuple. So
yes.
All right.
Okay. Well, with that, we actually have it giving us the invocation, which I guess is a good start. I think we're going to need to potentially do some recursion here, because it looks like we're going to need to. It looks like we're going to need to go through each tuple element, possibly.
So we need I'll give you a hint. Like, one of the ways that I saw a lot of people solving this was by making like a mapped. Basically making an object, like a mapped structure in here. It's always up to you what level of suffering you're in for in these challenges, but I'd be happy to kind of just show you a little bit of how people came across this. I personally could definitely not have done this one without looking up answers.
If we use a mapped type, though, we can at least do numeric indexes and get basically the same behavior as long as that works for tuples.
It will, yep.
Okay, great. Yeah, then that's obviously the easier way to go. So we may as well do that.
So, we have P and K key of T. There's going to be some kind of like, some kind of thing here. What I saw a lot of people do is make a helper type. Would you be offended if I showed you?
No, go ahead.
All right. So what I saw a lot of people do is make a helper type awaited. So taking a look at this takes in some T, and it says if T is a promise-like thing, then infer the value of that promise and recursively then call yourself with that value. And so like you're going to keep digging and digging. We kind of did this in a previous example, right? We did this. This is the awaited type that we did before. So if we build on the thing we already did, and if anybody's interested, go take a look at that video. It's challenge number 189. So if we do that, then we can just grab that value here and what goes in here is the values of each position at t. So we're going to say t of p. Make sense? What do you think?
That's easier than I thought, to be honest with you. I figured we were going to have to do some recursion on this one. But not
well, we do. I mean, we do the recursion here in awaited.
Oh, yeah. But I mean to iterate the tuple. I figured that was going to be a gnarly one. Turned out map types came to the rescue on that one.
They did. And it's interesting. Like, I personally would have never thought, this looks weird to me because it looks like we're returning an object, but I don't know. Do you have any color commentary on that?
Yeah, I mean, JavaScript arrays kind of do look like objects with keys that are numeric strings, and TypeScript seems to be happy to treat them relatively similarly, and I guess it just happens to work for tuples as well. I didn't actually expect it to, but it's very convenient that it does, because it's a lot simpler.
There's some learnings in here. If somebody has more on that what you said makes more sense to me than anything I've found so far. I'm always curious if somebody has more on that. I'd love to see kind of like a little discussion on when these mapped structures and arrays or tuples in this case are overlapping, because I would have expected this solution to have like something in here, but with, I would have expected it to be something like this. And then maybe we say like, we somehow loop through all the things in here, and then we call awaited somehow in here on all the values, but on t, but it just doesn't work that way. Here, could we do this? This doesn't work. Yeah, I wanted it to, but cool. All right, let's keep moving.